Mark Coleman here for Container Solutions, speaking to Matt Trifiro, SVP of Marketing at Mesosphere. Hello, Matt.
Hi, Mark. How are you doing today?
Very well. How are you?
I'm excellent.
We're actually having a heat wave here in Amsterdam at the moment, so I'm sat here trying to look like I'm not sweating. I don't know if it comes across in the camera or not.
Yeah, I don't see any gleam yet, but
Good.
We can edit it out. We can Photoshop it out, maybe.
We'll see how we get along. So this interview is going to be a part of Container Solutions DCOS week, which is coming up next week. I believe they've got a whole bunch of activities. For anyone who doesn't know who you are, perhaps you could start with a small introduction.
Sure. So I'm currently the SVP of Marketing at Mesosphere. I've been at Mesosphere for about 18 months. I started when the company was about 11 employees working out of a condo, and now we've crossed 100 employees, and we've launched our commercially available products. So I've been through the evolution of the company. Prior to working at Mesosphere, I was the CMO of Heroku, which I'm sure most of your audience has heard about.
Mm-hmm.
And prior to that, I've been marketing roles in a variety of companies. I was CEO of a venture-backed company. I was VP of marketing of a company in the 90s called Wing Communications, which went public. It was an interactive television software company.
Cool.
And so I've got a pretty long history in the software industry, and I feel like I'm coming back to my roots. I did business SaaS software for a while, but very early on in my career, I was a product manager for an operating system.
Really?
Called GEOS.
GEOS?
Yeah.
Never heard of it.
For the Commodore 64 and eventually for the x86 platform. And at the time, on the Commodore 64, it was the largest installed base graphical operating system in the world because it shipped with every single Commodore 64.
Really?
Yeah.
Okay, so that's a nice little bit of computer history trivia there.
Now I'm doing an operating system again. So
right.
I can come back to my roots.
Slightly bigger scale this time.
Yes.
Nice.
Data center operating system.
Yeah, exactly. So this is actually a perfect segue into speaking about DCOS. So for anyone who has had their head in the sand for a while, maybe you could give a short introduction to what is DCOS?
Yeah, so DCOS is a new kind of operating system, and unlike other operating systems that you're probably familiar with, from iOS to Windows to Linux, this is an operating system that operates at the scale of the data center. And what that means is it takes all the machines in your data center, whether they're virtual in cloud or in physical hardware, and it aggregates them into what looks like one giant computer, one giant pool of resources. And then you can actually program against that giant pool of resources. And you can run sort of existing, I won't call them legacy workloads, but in the sort of compressed web space, they're legacy workloads, so like Tomcat servers and Rails servers and Java apps and that sort of thing. But you can also build new distributed systems directly against the API. And when I say it's an operating system, I mean that literally.
Right.
It's not just a metaphor. I mean, people talked about a cloud OS and other things like that, but there's a lot of qualities to a real operating system that only exist in our technology.
So is that your way of, let's say, differentiating it from a cluster manager like CoreOS, for example?
Yeah. So we've taken a fundamentally different approach. The origins of the technology, which go all the way back to UC Berkeley 2009, started with looking at existing cluster management systems. I mean, cluster management's around quite a long time, mostly with HPC workloads. Mm-hmm. So the original research on Mesos at Berkeley's Ant Lab was around sort of cluster management. And Ben Hindman, who's a co-founder of our company and also the principal co-creator of Mesos, he had this really profound insight. He was thinking about the 4 cores in his laptop, mm-hmm. and was thinking that there really isn't any fundamental difference from a computer science perspective between the 4 cores in my laptop and 40,000 cores in my data center. I mean, you've got different kinds of latency issues, and you've got different fault domains, but essentially, from an operating system principle standpoint, it's the same. I mean, you would have some latency issues inside. I'm looking at my Mac now; it's a 4-core Mac, uh-huh. And you've got to contemplate the NUMA nodes. You get sort of memory latency issues. So abstracting up above the hardware has been a natural evolution in computer science, and it creates all sorts of catalysts in a marketplace. And so we look at this as the first new operating system that's been introduced since Android in 2007, and it's fun to just like Android and iOS created a category of applications around the form factor of the mobile device. Linux created a new category of applications around the form factor of the server. Mac OS and Windows and DOS and all of that created a new class of applications around the form factor of a desktop machine.
Mm-hmm.
We're creating a new class of applications, a new kind of developer around the form factor of a data center with a true operating system, all the sort of fundamental primitives you'd expect in an OS.
So when I hear a data center operating system, it makes me think maybe this is not for me. It sort of suggests that the minimum size of installation might be bigger than I would ever need. Is that the case, or is that just a naming clash?
It's not the case, but I understand why you think that way, because this technology scales to tens of thousands of machines, tens of thousands of nodes in full production, highly available, highly automated. But it operates on as small as 5 machines.
Mm-hmm.
And even if you're a startup and you're building a new service, startups. And for most of like my life as a startup entrepreneur, you've had to either build for time to market or build for scale. And most companies build for time to market. Like, we got to get our minimal viable product out there. We got to get customer feedback. And then when the customers show up and they get product market fit, they're paying back technical debt for 18 months.
Yep. So
you saw that at Twitter when they had to re-platform around the fail well, which they re-platformed around this technology. You've seen it at other companies like Yelp and HubSpot, and most companies that hit that success ramp run into these kinds of problems. And so one of the advantages of having this technology is you actually don't have to make that decision today. You actually can build for scale and developer productivity and high availability even as a startup.
So you touched briefly on the work that was done at Twitter. To what extent is DCOS based on Mesos, and then what would be the differences?
Yeah, so that's a great question. So Mesos is a very sharp, low-level technology, right? It's very fragile. You've got to have an engineering team basically to implement it,
mm-hmm.
and it's a kernel. It's a distributed systems kernel. So if you think of like the Linux stack, right, or even like again my Mac. I'm looking at my Mac talking to you on Skype.
Yeah.
My Mac has a BSD kernel inside it. But I'm not primarily interacting with that kernel, right? The kernel is insulated with all the other pieces that make my Mac OS an OS. So it's all the services that Apple has added. It's the Finder. It's the graphical user interface. It's all the service extensions. And so the relationship between the DCOS and Mesos is very similar to the relationship between Mac OS and BSD, or Android and Linux.
Right. So is that a good way to look at it? Like, if you really want to get your hands dirty, Mesos is fine. But if you want a bit more help, DCOS is going in the right direction. Or is it really about building extra functionality that can help multiple user groups?
Yeah, so I think if I were building a mobile app, I wouldn't start with Linux. I would start with Android or iOS.
Right.
So I think if you're building a modern app that's going to run at some scale in a data center, a mobile backend servers, Internet of Things, web servers, all that, I wouldn't even bother with Mesos, to be honest. We've made Mesos consumable by mere mortals, and we've added a lot of functionality and extensibility, and we've added an interface. So our command line is very, very powerful, and the command line spans the entire data center. You can do things like install a distributed system like Cassandra in a single command, and a minute later you've got Cassandra stood up. I mean, it took Airbnb when Florian, our CEO, was there. It took him 3 weeks to stand up a Cassandra cluster. And I can type one command and have a Cassandra distributed system available on my cluster in 30 seconds.
Which sounds nice.
It is pretty awesome. Yeah, I mean, you think about, so as a modern developer building back-end applications, you're like, okay, I need to build a real-time data pipeline.
Mm-hmm.
And so you say, well, what's the best practice there? What does that stack look like? And you say, well, I'm going to need Kafka, and I'm going to need a distributed data store like Cassandra or MemSQL, and I'm going to need Spark because I want to do analysis. And to actually set that up in the old world, you'd have an operations team that would provision 3 separate clusters, and then they would chef and puppet their way to standing up on one of them Kafka, on one of them Cassandra or MemSQL, and then on the other one, Spark.
Right.
And at the end of, a month,
mm-hmm.
you've got 3 statically partitioned clusters that are inelastic. When there's no Spark job and Spark queue, those servers aren't running. All that utilization is wasted, and you've got an operational complexity. And imagine if you've got not just like those 3 separate clusters, you've got dev, staging, and production. You've got a 9x9 matrix of statically partitioned clustered, gigantic amount of waste. A typical data center that's statically partitioned runs at like 10% efficiency.
Yeah.
Because every other bunch of these clusters is over provisioned for peak load, and when they're not at peak load, it's all wasted. And in this world, we're sort of re-platform on the data center operating system. It's literally DCOS package install Kafka, DCOS package install MemSQL, DCOS package install Spark. Now you've got your real-time data analytics stack, and you can go to town.
So is this really about enabling developers, like you said? Because you have this sort of dev swallowing ops thing, programmable infrastructure thing that's happening here. Is that really the goal, to sort of take away, or is it for operators as well?
Yeah, so it's very much for operators and devs. Although I do think that the trend is for developer-driven infrastructure, so to speak.
Yeah.
But that doesn't mean that operations teams, particularly in larger companies, aren't critically important. Because operations teams worry about security, they worry about network latency, they worry about access control, they worry about how do you do disaster recovery, and those functions, while they'll be increasingly automated, aren't something that you want your developers thinking about. What you want your developers to do is be able to build applications faster. So it's really both. It's about enabling the data center operator to focus on more things that are adding value as opposed to just these sort of redundant tasks. I mean, when a server goes down, nobody should get paged, right? Nobody at Google gets paged when a server goes down. But in today's large enterprise data centers, and even startups running on Amazon cloud, like somebody gets paged when a server goes down. Mm-hmm. That should never happen. Like all those tasks is automatically restarted, and when somebody comes in the morning, there should be a note. Go kickstart that machine.
Figure out what happened. Yeah.
Yeah, figure out what happened. And so I think to answer your question, yeah, it's about improving the efficiency and automation in the data center, so the data center operators can add more value to the organization rather than doing things that computers can do better. But also, the data scientists and the developers are essentially customers for the data. I mean, the whole reason an enterprise has a data center is because software is eating the world, and they need to differentiate through software.
Yeah.
So ultimately, it is very much about enabling the developer and the data scientist, but the operator plays a very crucial role.
Okay, clear. I want to get you to clear one thing up officially for me, because if I had €1 for every time somebody asked me for the difference between Mesos and Mesosphere, I'd have like €5. So just to be clear, Mesos is a project which is supported by the Apache Foundation.
Yes, that's right.
Mesosphere is a separate
company. Overlap.
Right.
Because,
okay.
Our co-founder Ben Hyman was the creator of it. He's
yep.
a VP at Apache and is the chair of the Mesos project. And as an open source project, we and Twitter are the two largest committers. We have probably a third of our engineers working on the Mesos core open source. We're big contributors back into that open source. Mm-hmm. It's a core part of how we believe the technology needs to evolve in an open source world. So Mesosphere, I mean, today we are the commercial entity around the Mesos project, but our product is this data center operating system, which recognizes that Mesos' role is really as an API for the kernel functionality, abstract the hardware, and provide some of the low-level scheduling capabilities.
Okay. Now we've solved that one then. So I want to look towards the future now. Last couple of questions. What's in the pipeline? Obviously, you had DCOS release earlier this year.
Yes.
What's coming up in the next 6 months that people should keep their eyes on?
So in June, early in June, we launched generally available 2 editions of the DCOS. The Community Edition, which has no license fee, it's free to use. Today, it's only for the cloud. It's generally available for Amazon Web Services. You just click to deploy it on our website. It's in various stages of testing on Google Compute as well as Microsoft Azure. Mm-hmm. We also made generally available our Enterprise Edition. And the Enterprise Edition is the paid edition, and it includes enterprise-grade features. It's where we primarily make our money. We sell it on a per node, per year subscription basis, which includes support, but also includes our enterprise-grade features. So when you look about where are we going to be spending our time, it's really on those 2 ends of the barbell, which is making the community edition easier for people to adopt, easier for people to self-support, easier for people to partner with folks to run that in production, as well as adding unique enterprise-grade capabilities, security, storage, advanced scheduling, advanced networking capabilities to the enterprise edition.
Okay, clear. So my last question then really is the whole Mesos then DCOS story began with Ben Hyman's realization that there was really no difference between what was in his computer and 10,000 of what were in his computer, which leads me to think, where do you think this is all going? Where do you imagine this being in 12 months? Because, of course, I can imagine more of these jumping out, a bit of competition, and then... But, okay, so it's now stabilized. Everyone's running clusters. No one uses local dev environments anymore. Then what?
Well, people do use local dev environments still. I mean, there's a lot of inertia.
But this is a future thinking idea.
Oh yeah. So I do think that people. I do think the local dev environment is. I mean, so I talk about me as a marketer. I had a Google Docs moment, right? I was a Microsoft Office user forever, and I laughed at Google Docs, right? Like, how can you use a document processor without like a tab, right? I didn't have tabs. And then I went through this transition where I never lost a document, I never had to save, it had enough functionality, the need to print was largely diminished, and it had like group collaborative editing. And there was just this click. Like, I don't create a local document ever anymore. And I think developers, that it's so tight. I got to create my local dev environment. I have, give me the vagrant image so I can like hack on it. And what happens is you're building data center applications. The deviation from what you can simulate on your local machine and what you actually have in a production environment is the delta is so large that it makes no sense. So yeah, I think our laptops are going to be portals into our data center computer, and we're going to treat that as our development staging and production environment. In fact, we have a CLI that you install locally, but it commands your data center, so you can do things like DCOS tail, and you can tail a process across hundreds of thousands of machines as if it was one machine. You don't have to like SSH into this box and SSH into that box, and you see these things, and it just the light bulb goes off. People are like, wow, it is like one big computer. And we've got a prototype version of the CLI that actually runs on the cluster. So it runs in a web browser on the cluster.
So then everything is in the matrix.
Yeah. Why wouldn't you do your editing and your command line and your staging, production, pipelining all on your data center computer? Why would you like force yourself to create this kind of simulacrum on your local box? We're going to go through that transition.
That's fantastic. Unfortunately, Matt, that is all we have time for. So I want to say a big thank you for answering these questions for us today. I think that's about, that is literally it. It's a shame. We could go on for a long time. But Matt, thank you very much.
It's been a pleasure. I'm sure we'll do it again.
Thanks. Bye.